Okay, so we are looking at 11, 12, and 13 from finding density. So for 11, wood board gives the length, width, the depth. They give us the density. We've got to go and paint these. So from question 9, we know the surface area of one board is 180.5 inches squared. We have to add 2 coats to every one of those. So you got to make sure you're doubling your answer depending on where you're going. But if I look at 2 coats, that means one board has 361 square inches. I've got to go 25,000 boards altogether. So 25,000 times 361 gives me the 9,025,000 inches squared. Then I also know if 1 gallon gives me 576,000 square inches, how many gallons is it going to take me to get to the 9,025,000 square inches? So I take and divide those two out. So I add an extra 0 there. So that's 156.68 gallons. If you were to go to the hardware store today, please don't go to the hardware store today. But if you were, you can't purchase 6/10 of a gallon. So you would buy a full gallon there of 157. So most of you are just not doubling to actually get the full answer there. You're coming up with something around 78. But that's only 1 coat. We need to do 2 coats for all of those. So then if you move on to 12, I won't give you the answer 12, but I'll walk you through that. With 12, same wood board, but this time we're going to ship them. So if we look up to previous answers we've got from question 10, from question 10 itself, we know that the weight of one of the boards is equal to 1.87 pounds. So with that 1.87 pounds, we then know that we need to ship out 25,000 of them. So from the 25,000 of them that we ship out, we got to take that 25,000 times that 1.87. And with that, we get the weight of all those boards being 46,750 pounds. So if we look at the question itself, in order to ship 1 pound of packaging, it costs $4.25. So we want to go ahead and ship the 46,750 pounds. So when we go ahead and we ship all of those, we end up with that cost. So that you can go ahead and do the calculation with that. So if we look at question 13, we have got same wood board, but this time we're not going to have a 3.5 by 17. We are going to reduce that board, the original board, into 1.5 by 5.5. So we're changing the width and the height. I'm going to write down length and width of that piece there. So that's that original surface area of the cross-sectional area. Density weight stays the same, still the same type of material, so 0.021. And then we have got the new weight needs to be 3.2. So we have a formula for weight. We have a formula for weight. Weight is equal to volume times density. We're doing a wood rectangular prism. So the volume for rectangular prism is length times width times depth. So we plug in the weight, 3.2. Volume, we know the length, we know the width, we don't know the depth. We just don't know one of them. It doesn't matter. They're interchangeable. Called the commutativity law of multiplication. So we plug all that in. That's there. We do know the density weight there of 0.021. And then all you're doing is solving for that question mark there. Once you get that, you'll be able to solve for 13. Any other questions? Let me know. Thanks.